Security, and especially cybersecurity, are paramount these days, with large organisations such as Santander and Live Nation falling foul to hackers in the last week. No organisation can be seen as safe. Now, whilst we can't cover everything, we can look at a simple way that people can try and gain access to your SSH server and ways in which you can protect it. This is a simple overview, but will get you started. So I'm certainly up for it if you are up for it to come on our journey as we investigate the good and the bad on the internet. So come on and welcome to this practical demonstration on enhancing security. We'll be using AWS Fail to Ban and the Metasploit framework. We will be setting up a remote SSH server on AWS, monitor and analyzing failed login attempts via SSH, and then implementing security measures to protect against these attacks. This hands-on demonstration will provide you with a comprehensive understanding of how to detect, analyze, and mitigate security threats effectively. So step one is monitoring, and of course we all should be monitoring very frequently. You might be happy if you don't monitor your logs because you don't know what's going on, but that doesn't make your system any safer, does it? So step one is monitoring, and it might seem a little bit low tech, but monitoring your logs is always the way to start. Now, of course, I can automate it by having processes monitor my logs for me, but let's connect into my remote AWS system. So I'm going to connect as a lab admin user, and if I can type the IP address that's scribbled on my bit of paper, I should be able to get into this system. I'm using password-based authentication, so I'm going to need to type in a password, and I'll be careful to type it correctly. But of course, the first time I connect to the system, I have to accept the fingerprint, the shortened version of the public key to trust. Now carefully type my password, and now I'm into the system. And everything might seem very good, especially if I don't look at the logs. The first thing to understand is that this is a new system. It is only newly deployed. It hasn't been sat here for days. So let's go through and work out how long it has been up before we start looking at the attacks that have been happening. Using the command uptime, we can see that this system has been up for 3 hours and 34 minutes. Yes, it's been up less than 4 hours, so not a long time, but you'll be surprised, and I think you really will be surprised, as to how many possible attacks are already underway for our SSH server. If I go through and take a look at the logs, and with modern Linux systems we can use the journalctl command to be able to look at our logs, but to filter them I can specify that I want the unit SSHD. When we look at this, we're then able to see there's been an immense amount of activity already against my server. Most of them appear to be failed password attempts, although often they've got invalid keys as well that are trying to be used for authentication. But let's go through and drill down a little bit more to look at our failed login attempts. I can use -G to include grep within my filter, and then we can go through and look for failed password. So this was the message that we were seeing predominantly in the output, and now we're only looking at the failed login attempts. There certainly seems to be a lot. How many? We'll send them, pipe them to word count -L, and we can see that we've got 246. That's in 3.5 hours. Now, to be honest, when I start mentioning regular expressions, most people are going to tune out. But we want to be able to just get a list of IP addresses to get a better idea of what's going on. So adding that little bit of complexity to your query can really work. Now, you are going to find this ugly, but let's take a look at it. If I up arrow key, I've already added the command in previously because, obviously, like you, I don't want to have to type it in. I really haven't got that far to go to be able to get to a regular expression that extracts just the IP addresses. So we're really looking at IP addresses for version 4, numbers 0 through to 255. It looks a little complex, I know, but we're also piping the output to sort -u, which is going to give me unique occurrences. Because obviously these IP addresses will be used multiple times trying to access multiple user accounts with multiple different passwords. So we can see out of those 246 attempts, we've got down to a list of IP addresses, and we can then start looking at banning these IP addresses via a firewall rule. But better than that, we can also automate the process. Now, in step 1, we have identified a problem. We identified the problem by monitoring our logs. We can automate some of that process by installing products like Logwatch, or taking a little bit further with the LogCheck database. Now this then brings us nicely to step 2, where we need to understand the attack. And this is then getting into the minds of the hackers and understanding what tools they will be using. And here we are back on the command line of my Linux system. A Linux system where you can learn how to do some penetration testing yourselves, so you can really start to understand what's going on with this type of SSH attack that we are seeing. Often people think it will be people with computer degrees or computer scientists on the other end of a keyboard that are implementing these attacks. But if I show you by taking a look at some standard files that I have here, by looking in my USR share and looking at the directory for Metasploit, I have Metasploit framework installed, and inside of this I have a data directory with some word lists, and this comes with the package, so these are not word lists that I have created. Looking at the Unix users.txt, then these are common usernames that might be found on Unix systems, and of course this applies to our Linux systems as well. So this is where we can get a list of usernames to try. If I just jump out of this and go back up to my less command, and I can then go through and change this to passwords.txt, and these are common passwords that may be in use. So now I've got a list of usernames and a list of passwords. I can then try these against the SSH server. And to implement this, I'm going to use the MSF console, the Metasploit framework console. We can allow it to fire up, but once it has then fired up, I will have standard exploits that are built into this. One of those exploits is going to allow me to try and log on to my remote SSH server with those usernames and passwords. So if I now go through and I can use auxiliary scanner SSH, I can use tab completion as I'm going through. And of course, the tab completion will show me all of the tools that are available. I'm going to take a look at SSH login because that's what we want to do. Try and log in and gain control of the system. But there are other tools that I could make use of here as well, so it's worth noting. So let's go through. From the prompt, I can clear my screen, and then I can go through and set the target. Make sure, and this is serious now, you are setting a host that you control. This shouldn't be just a random server. This should be one of your virtual machines or virtual machines deployed that you are managing currently in a cloud provider. So that set the IP address of the system that we were looking at earlier. We can now go through and run our scan. Let's call it scan. That's a nicer word than attack. And I'm going to set my user file to be the user list that we were looking at before. So we can put it through to the path USR share Metasploit, and dropping down into the data word lists, and then the Unix underscore users.txt. I can use tab completion here as well, so you don't have to worry about typing. And I'm going to do the same thing with the pass underscore file, so my list of passwords. And I'm going to have that then set similarly as we then navigate down to USR, share, Metasploit framework, data, word lists, and then Unix underscore passwords.txt. Now you can see the brute force attack is starting. Well, we're then trying to log in. If I go back to the Ubuntu AWS server, and let's just change our journalctl command to look for our unit SSH, but I can use the -F, so I am following the end of the journal log. And we can see then that it's just a heap of user attempts, SSH login attempts, that are failing. Invalid user. So we can see that this is working. And it's this type of behavior that we want to prevent. So let me return back now to my Linux client. I can Control-C to stop that attack. And we can return to summarize what we have seen during this simulated attack on our SSH server. To be able to truly defend your system, you have to get into the mind frame of the hackers. So you've been trying out a little bit of penetration testing yourselves. Using the Metasploit framework, which ships with Kali Linux, you are able to make use of their supplied list of usernames and supplied list of passwords to be able to try and log in to your remote server. I am making it clear that it is your remote server. We want to get into the mindset of a hacker. We're not becoming hackers ourselves. So in step 3, we're going to look at how we can defend ourselves and defend our server, looking at ways that we can mitigate this attack and future attacks like it. Come on, we've got some defense to make. So working back on our poorly sick AWS server, we can see since we've been away, there's been even more people trying to take a poke at us and trying to gain control to own our system. Well, we're not going to let them. We're going to fight back. So we're going to install some software that's going to automate adding these people to a ban list, or at least the IP addresses. So if we add in failed to ban, failed logins to be banned, banned by the firewall. So putting automated firewall rules to block these IP addresses. When I say these IP addresses, it will work from this time on. It isn't retrospectively go back and look for those IP addresses that have been used in the past, but no doubt they're also going to be used in the future. So having installed it, we do need to set up something called a jail, looking at which service we want to try and protect. So clearing my screen and then just running sudo and vim, but remember you can use any text editor, and taking a look at etc, fail to ban, and when I do jail dot, if I use tab completion, we've got the main configuration file, which sets all of the defaults, but I've got the jail.d where I add in my own configurations, and I'm going to create a configuration called sshd.conf. With that done and dusted, we can then start defining our jail name. So that's in the square brackets. We can make sure that this is enabled. So enabled equals true. And we can specify which port we want to look for. So we can be looking for port SSH. So our port 22, we can put a port number or a port name. We're looking in our log for activity to do with the SSH daemon. And the log path, the log file that we're going to look in, is going to be /var/log and the auth.log. We can specify a max retry, so how many failed login attempts we're going to allow. So we're going to have a maximum of 3 login attempts, and we can specify the period that this will take place in as well. So if I put in the directive find time, and we're going to put this through to 15 minutes. So 3 failed login attempts within a 15-minute period it's going to block you. And how long do we block you for? Well, we're going to add you to the firewall rules for 1 day. So this is really going to be good enough to make sure that people who do need to get in can get in, and those that shouldn't can't. Let me just correct that spelling mistake, and we are done. And now I can make sure that I restart the fail to ban service. By restarting the service, we're going to ensure that the service reads the configuration that we have just written. We also have a client so we can actually see the activity that is happening. So if I go through and look at my fail to ban client and look for the status of the SSHD jail I've just created, well, we can see at the moment nobody is banned. So it doesn't retrospectively ban or block IP addresses. But if I go back to my Kali Linux system, and on my Kali Linux system, if I then go through and run the same attack as I did before, we should find that I lose my connection as I am banned or firewalled from accessing the system. So we can see we've started our brute force attack, but returning through to the AWS server, I'm no longer in control of it. I can't move up and down. I can't do anything. I've lost my SSH connection. So this is good. I have been banned. We know it's working. We could also see that the attack was quite quick. Very quickly it stopped. But if I try and execute again, we can see that it stops straight away as we realise we have no access to this system. So the mitigations are in place and we have proved that they are working. Of course, we still need to monitor, but we've installed the fail to ban service. The fail to ban service will continue to monitor those failed login attempts and decide whether or not they meet the criteria to ban them. We've created our own jail file, the sshd.conf, that specifies the periods, the criteria to look for. We should be able to now continue with the rest of our day with a little bit more peace, knowing that we are protected.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.